Hello, in this lecture we'll find out the area of a circle. In the drawing we have quadrilateral ABCD. Inside this quadrilateral we have this circle. In addition, we know that side AB of this quadrilateral is equals to 2 units in its length. Side BC also side BC equals to 8 units in its length. Side DC is also equals to 8 units in its length. This is angle ABC that is equals to 90 degrees in its side, and this angle DCB, it is also equals to 90 degrees. Again, our mission is to find out the area of this circle. Okay, so in the first step, we'll do a construction. That is to say, we'll extend side DA and side CB of this quadrilateral ABCD by a straight line until they touch each other. So this is their touching point. We define the touching point of the extended side DA and side CB as M. We define this angle as theta. We will focus on the right big triangle, triangle DCM. On the right big triangle, triangle DCM. On this big right triangle, triangle DCM, this angle equals to theta, this angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees, it is equals to 180 degrees. That is the sum of the angles in any triangle. In the next step, we focus on this line segment BC. Line segment BC is one side of quadrilateral ABCD, therefore it is absolutely a straight line. And we actually extended the straight line BC by straight line, and the result is CM. When you extend the straight line by straight line, the result must be a straight line. Therefore, CM is a straight line. So if you focus on the upper side of the straight line CM at point B, here the sum of the angles must be equal to 180 degrees according to the rule. Then the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of CM at point B? We have this angle is equal to 90 degrees plus this missing angle. In total, they must be equal to 180 degrees according to the rule that I mentioned. Therefore, the missing angle must be equal to 90 degrees. In order to complete the sum of the angles on the upper side of CM at point B to 180 degrees, the missing angle here must be equal to 90 degrees in its size. So in the right triangle ABM, the right small triangle ABM, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta, according to the same logic. Only the same logic, the same rule that the sum of the angles in any triangle is equal to 180 degrees. Okay. In the next step, we will prove that the right big triangle, triangle DCM, is similar to this right small triangle, triangle MBA. So I write it down. The right big triangle, triangle DCM, is similar to the right small triangle, this right small triangle, triangle MBA. So, why those two right triangles are similar to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. So actually, this is angle DCM. This is angle DCM in the right big triangle DCM. And it equals to this angle, that is actually angle ABM in the right small triangle MBA. Repeat again. Angle DCM in the right big triangle DCM equals to angle ABM in the right small triangle MBA. They are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta, that is a common angle, it belongs to both triangles, so we can write down that angle theta equals to itself as a common angle that belongs to both triangles. So if we relate to this angle, angle theta, as it is belong to the right big triangle DCM, it will be called, or it will be defined as angle DMC. And it equals to itself. So if we relate to angle theta as it is belongs to the right small triangle MBA, it will be called angle AMB. I repeat again. This equation means that angle theta equals to itself. We just call to angle theta two different names. Angle theta equals to itself is a common angle that belongs to both triangles. And finally, those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. So actually this is angle MDC. In the right big triangle DCM, and it is equals to this angle, that is actually angle MAB in the right small triangle MBA. Repeat again. Angle MDC in the right big triangle DCM equals to angle MAB in the right small triangle MBA. They are both equal to 90 degrees minus theta, therefore they are equal to each other. So we actually proved that all the three angles of the right big triangle DCM are correspondingly equal to all the three angles of this right small triangle MBA. Therefore, those two right triangles are similar to each other according to angle similarity rule. So I write it down. The right big triangle DCM is similar. This is the sign of similar to the right small triangle, triangle MBA, according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that side DC in the right big triangle DCM over side AB in the right small triangle MBA equals to side CM in the right big triangle DCM over side BM in the right small triangle MBA. Repeat again. We derive that DC over AB equals to CM over BM. Okay. DC equals to 8 units in its length. DC equals to 8 units in its length over AB. AB equals to 2 units in its length. And it is also equals to CM over BM. CM, what is the length of CM? From the domain it is very easy to see that CM in total equals to CB plus BM. CM equals to CB plus BM. So CM equals to CB, that is 8, plus BM, that is the missing side. So in total CM equals to 8 plus BM. So here CM equals to 8 plus BM over BM. So in conclusion, found that 8 over 2 equals to 8 plus BM over BM. 8 over 2 is 4, so 4 equals to 8 plus BM over BM. So here we will multiply this equation by BM, and we will get that 4 times BM equals to 8 plus BM. Here we subtract BM from this equation, and we'll get that we'll get that 4BM minus BM is 3BM equals to 8. 3BM equals to 8. Here we will divide this equation by 3, and finally we get that BM equals to 8 over 3 units in its length. BM equals to 8 over 3. You can write here in the drawing that the missing side BM equals to 8 over 3 units in its length. In the next step, we'll focus on this small right triangle MBA, and we'll implement the Pythagoras theorem in this small right triangle MBA in order to find out the length of the hypotenuse AM. This is the only side that is missing here. Okay. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in this right triangle MBA is AM, therefore the square of the hypotenuse is AM squared, and it must be equal to AB squared plus MB squared. Repeat again, according to the Pythagoras theorem, in the right triangle MBA, AM squared equals to AB squared plus MB squared. So AM squared, that is the square of the hypotenuse, equals to AB squared. AB is 2, therefore AB squared is 2 squared, that is 4, plus MB squared. We just right now found out that MB equals to 8 over 3, therefore MB squared is 8 over 3 squared, that is actually 64 over 9. So AM squared equals to here we have 4 plus 64 over 9. We will multiply 4 by 9 and then we will divide it by 9 in order to overcome factor with 64 over 9. So 4 times 9 is 36. So in total, in the numerator of this expression, we will have 36 plus 64 divided by 9. 36 plus 64 is 100 divided by 9. Here we'll take a root, so AM squared equals to 100 over 9. So here we'll take a root for this equation, and we get that AM equals to the square root of 100 over 9. The square root of 100 over 9 is the square root of 100, that is 10, over the square root of 9, that is 3. So in conclusion, we found out that the length of the hypotenuse AM is actually equals to 10 over 3 units. AM equals to 10 over 3 units in its length. Here the hypotenuse AM equals to 10 over 3 units. In the next step, we will do another construction. That is to say, we'll draw perpendicular on side BC in such a way that the perpendicular on BC will be also tangent to this circle. It is absolutely possible. Why? Because we can draw the perpendicular on BC on any point on BC. We have infinite points on BC that we can draw the perpendicular. So we'll find the point on BC that will make also tangent to this circle. Okay. So first of all, this angle equals to 90 degrees, and this angle also equals to 90 degrees, according to our construction. We'll define the touching point of the perpendicular inside BC as point T. We will define the point of tendency of the perpendicular with this circle as K. We will extend the perpendicular TK by straight line until it touches side AD. We will define the touching point of the extended perpendicular TK with side AD as point S. By doing this construction, we created the right middle triangle, triangle MST. In this right middle triangle, triangle MST, this angle equals to 90 degrees, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. Okay, so right here, the missing angle here must be equal to 90 degrees minus theta in its size. In the next step, we define the center of this circle, this point as O. We will define the point of tendency of tangent AB with this circle as L. And finally, we will define the point of tendency of tangent BT with this circle as H. We will define the radius of this circle as X, and we will join points O and H together by a straight line. Point O is the center of the circle, point H is the point on the circle itself. This is exactly the definition of a radius. Therefore, OH is the radius of the circle is equal to X, according to our definition. So we can implement here rule 1. I'll repeat quickly on rule 1. According to rule 1, a tangent to the circle is perpendicular to the radius drawn to its point of tendency. In the drawing, we have a circle, and we have also tangent AB that is tangent to this circle, point M. Point M is the point of tendency. And we have also the radius OM that is drawn to point M. And whenever you have a radius that is drawn to point M, that is the point of tendency, then tangent AB will be perpendicular to the radius MO. If AB is perpendicular to MO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to this rule, rule 1. Actually, we can implement rule 1 in our drawing. Why? Because in our drawing, we have the radius OH that is drawn to point H. Again, the radius OH is drawn to point H, that is the point of tendency of tangent BT with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent BT will be perpendicular to the radius HO. If BT is perpendicular to HO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees. Likewise, we join points O and L together by a straight line. Line segment OL is the radius of this circle, that is equal to X, and here again we have the radius OL that is drawn to point L. Therefore, according to rule 1, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Likewise, we join points O and K together by a straight line. Line segment OK is the radius of this circle that is equal to x. According to our definition, again we have the radius OK that is on to point K. Therefore, according to rule 1, this angle equals to 90 degrees and this angle also equals to 90 degrees in its size. In the next step, we'll focus on the small quadrilateral LOBH. In this small quadrilateral LOBH, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees plus the size of the fourth angle. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing angle here must be equal to 90 degrees in its size. In order to complete the sum of the angles inside this quadrilateral LOBH to 360 degrees, the missing angle here must be equal to 90 degrees in its size. So, we have here 4 right angles inside quadrilateral LOBH. Any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we relate to this quadrilateral LOBH as a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. That is to say, side LO equals to side BH. But LO equals to x, therefore BH must be also equal to x. We repeat on the same process on the small quadrilateral OKHT. Inside this small quadrilateral OKHT, we have 1, 2, 3 right angles. Therefore, the fourth angle must be also equal to 90 degrees. So, quadrilateral OKHT is 4 right angles. Therefore, we can relate to this quadrilateral as a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. That is to say, side OK equals to side HT. But OK equals to x, therefore HT must be also equal to x units in its length. So in conclusion, found out that the length of line segment BT, in total it is equal to x plus x, that is 2x. So write it down. Line segment BT equals to 2x units in its length. In the next step, we'll prove that the right middle triangle STM is similar to the right small triangle MBA. Okay, so I write it down. The right small triangle STM is similar, the right middle triangle STM is similar to the right small triangle MBA. So why the middle triangle is similar to the small triangle? The middle triangle STM is similar to the small triangle MBA. First of all, those two angles, they are both equal to 90 degrees, therefore they are equal to each other. So this is angle STM. In the right middle triangle STM, and it is equals to this angle, that is actually angle ABM in the right small triangle MBA. Repeat again. Angle STM in the right small triangle STM equals to angle ABM in the right small triangle ABM. Therefore equal to 90 degrees. Therefore they are equal to each other. In addition, this is angle theta. That is a common angle. It belongs to both triangles. So we can write down that angle theta equals to itself as a common angle that belongs to both triangles. So if we relate to angle theta, this angle theta, as it is belongs to the middle triangle, triangle STM, it will be called angle SMT. And it equals to itself. So if we write to angle theta as it is belong to the right small triangle MBA, it will be called angle AMB. Repeat again. This equation means that angle theta equals to itself. We just call to angle theta two different terms. Angle theta equals to itself is a common angle that belongs to both triangles. And finally, those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. So this is angle MST. In the right middle triangle STM, and it is equal to this angle. This is actually angle MAB in the right small triangle MBA. Repeat again. Angle MST in the right middle triangle STM equals to angle MAB in the right small triangle MBA. They are both equal to 90 degrees minus theta, therefore they are equal to each other. So we actually proved that all the three angles in the right middle triangle, triangle STM are correspondingly equal to all the three angles in the right small triangle, triangle MBA. Therefore, those two right triangles are similar to each other according to angle similarity rule. So I write it down. The right middle triangle, triangle STM is similar. Again, this is the sign of similar to the right small triangle, triangle MBA, according to angle similarity rule. And from the fact that the right triangle is similar to the small triangle, the small right triangle, we will derive that the following relationship exists between their sides. We will derive that side ST in the right middle triangle STM over side AB in the right small triangle, triangle MBA is equals to side TM in the right middle triangle STM over side BM in the right small triangle MBA. Repeat again. We will derive that ST over AB equals to TM over BM and it is also equals to side SM in the right middle triangle STM over side AM in the right small triangle, triangle MBA. So, in conclusion, found out that ST over AB equals to TM over BM, and it is also equals to SM over AM. ST is the missing side, so we leave it as it is, over AB. AB is 2, so we substitute AB by 2. Okay. And it is also equals to TM over BM. What is the length of TM? From the drawing, it is very easy to see that Tm equals to Tb plus Bm. That is to say, Tm equals to Tb, that is 2x, plus Bm, that is 8 over 3. So in total, Tm equals to 2x plus 8 over 3. So we substitute Tm here by 2x plus 8 over 3 divided by Bm. What is the length of Bm? Bm equals to 8 over 3. So we substitute Bm in this equation by 8 over 3, and it is also equals to Sm over Am. What is the length of Sm? From the drawing, it is very easy to see that Sm in total equals to Sa plus Am. That is to say, Sm equals to Sa, that is the missing side, plus Am, that is 10 over 3. So in total, Sm equals to Sa plus 10 over 3. Here, Sm equals to Sa plus 10 over 3 divided by Am. What is the length of Am? Am is 10 over 3. So in conclusion, we found out that St over 2 equals to 2x plus 8 over 3 over 8 over 3, and it is also equals to Sa plus 10 over 3 over 10 over 3. So we focus on this long equation. In this long equation, those two sides they are equal to each other. So we create equation 1 from those two sides that are equal to each other. So according to equation 1, St over 2 equals to 2x plus 8 over 3 over 8 over 3. So according to equation 1, St over 2 equals to, here in the other side of the equation we have 2x plus 8 over 3. So we multiply 2x by 3 and then we divide it by 3 in order to create the common factor with 8 over 3. 2x times 3 is 6x, so in total, in the numerator of this expression, we will have 6x plus 8 divided by 3, and we have to divide it also by 8 over 3. So in this side of the equation, we have 3 in the numerator and 3 in the denominator, so 3 will get cancelled, and we're left only with 3 cancelled 3. We have St over 2, that is equals to 6x plus 8 over 8. So here we'll cross multiply this equation 1, and we'll get that according to equation 1, 8 times st equals to 6x plus 8. 8 times st equals to 2 times 6 plus 8. Okay, here we'll divide this equation 1 by 2. 8st over 2 is 4st. This equals to 2 over 2 is 1, so in the other side of the equation we left only with 6x plus 8. Here we'll divide this equation 1 by 4, and finally we get that st, according to equation 1, st equals to 6x over 4 is 1.5x, plus 8 over 4 is 2. So in conclusion we found out that st equals to 2 plus 1.5x. So you can write here that st, this line segment st equals to 2 plus 1.5x. We will continue to focus on the long equation. In this long equation, those two sides are also equal to each other, so we will create equation 2 from those two sides that are equal to each other. So according to the second equation, we get that 2x plus 8 over 3 over 8 over 3 equals to SA plus 10 over 3 over 10 over 3. So in this side of equation 2 we have 2x plus 8 over 3. So here we will multiply 2x by 3 and then we'll divide it by 3 in order to become factor with 8 over 3. 2x times 3 is 6x, so in total in the numerator of this expression we will have 6x plus 8 divided by 3, and we have to divide it also by 8 over 3. And it is also equals to another side of the equation we have SA plus 10 over 3. So here we multiply SA by 3 and then we divide it by 3 in order to have a common factor with 10 over 3. SA times 3 is 3SA. So in total, in the numerator of this expression, we have 3SA plus 10 divided by 3, and we have to divide it also by 10 over 3. So in this side of this equation 2, we have 3 in the numerator and 3 in the denominator, so 3 will get cancelled. And the other side of this equation 2, we have 3 in the numerator and 3 in the denominator, so 3 also will get cancelled. What is left from equation 2 after we cancel 3 from both sides of this equation? What is left is actually, in this side of equation 2, we left only with 6x plus 8 over 8 equals, in the other side of equation 2, we left only with 3 times SA plus 10 divided by 10. So here we cross multiply this equation 2, and we get that according to equation 2, 10 times 6x plus 8 equals to 8 times 3SA plus 10. Okay. So here we divide this equation 2 by 2, and we get that 10 over 2 is 5. Inside the brackets we have 6x plus 8 is equals to 8 over 2 is 4. Inside the brackets we have 3SA plus 10. So here we'll open the brackets on both sides of this equation 2, and we get that according to equation 2, 5 times 6x is 30x, plus 5 times 8 is 40. That equals to 4 times 3SA is 12SA, plus 4 times 10 is 40. So here we have 40 on both sides of this equation. So 40 will get cancelled, and we left only with 30x, that is equals to 12SA. Here we divide this equation by 12, and finally we'll get that SA equals to 30x over 12 is 2.5x. So we found out that the length of line segment SA is 2.5x. This line segment SA equals to 2.5x in its length. In the next step, I will copy this quadrilateral ASBT with the circle that is inscribed inside it in a new page, and we will implement on this quadrilateral with the circle rule 2. So actually this is quadrangle ASBT with the circle that is inscribed inside it that I copied from the original drawing. So here we'll define the point of tendency of tangent AS with this circle as K. We define the point of tendency of tangent AB with this circle as M. We define the point of tendency of tangent BT with this circle as G. And finally, we define the point of tendency of tangent ST with this circle as H. In the next step, we'll implement on this drawing rule 2. I'll repeat quickly on rule 2. According to rule 2, the lengths of two tangents from a common standpoint to a circle are equal. In the drawing we have a circle and we have the common standpoint point P. From the common standpoint point P we have two tangents to this circle, tangent PA and tangent PB. And according to this rule 2 they are equal to each other. That is to say the lengths of two tangents are equal to each other. That is to say the length of PA is equal to the length of PB or PA equals to PB. We can actually implement rule 2 in our drawing. Why? Because in our drawing, if we focus on the common standpoint point A, from the common standpoint point A, we have two tangents to this circle, tangent AM and tangent AK. And according to rule 2, they are equal to each other. So AM, the length of tangent AM is equal to the length of tangent AK according to rule 2. So if we define the length of tangent AM as A, then the length of tangent AK must be also equal to A because they are equal to each other. In conclusion, we found out that AM equals to AK equals to A. In the next step, we will focus on this common external point, point B. Okay. From the common external point, point B, we have two tangents to this circle, tangent BM and tangent BG. And according to rule 2, they are equal to each other. So that is to say, BM equals to BG according to the same rule, rule 2. So if we define the length of tangent BM as B, then the length of tangent BG must be also equal to B because they are equal to each other. So in conclusion, we found out that BM equals to BG equals to B. Only to the same rule, rule 2. Likewise, we focus on the common standpoint, point T. From the common standpoint, point T, we have two tangents to the circle, tangent TH and tangent TG. According to rule 2, they are equal to each other. That is to say, TH equals to TG. The length of tangent TH is equal to the length of tangent TG according to the same rule, rule 2. So if we define the length of tangent TG is C, then the length of tangent TH must be also equal to C because they are equal to each other. In conclusion, we found out that TH equals to TG equals to C. And finally, we focus on this common external point, point S. From the common external point, point S, we have two tangents to this circle, tangent SH and tangent SK. And according to rule 2, they are equal to each other. That is to say, SH equals to SK according to the same rule, rule 2. So if we define the length of tangent SK as D, then the length of tangent SH must be also equal to D because they are equal to each other. So in conclusion, we found out that SH equals to SK equals to D. In the next step, we will add side AB to side ST. What is the value of AB plus ST? AB equals to A plus B and ST equals to C plus D. Therefore, in total, AB plus ST equals to A plus B plus C plus D. In the next step, we'll add side AS to side BT. AS plus BT. What is the value of AS plus BT? From the drawing, it is very easy to see that AS plus BT in total it is equals to A plus B plus C plus D. Again, AS plus BT equals to A plus B plus C plus D. So AS plus BT also equals to A plus B plus C plus D. So actually found out that those two expressions, they are both equal to A plus B plus C plus D, therefore they are equal to each other. So you can write down that the expression AB plus ST equals to the expression AS plus BT. Repeat again, we found out that AB plus ST equals to AS plus BT. AB equals to 2 units in its length, therefore we substitute AB by 2. Plus ST. What is the value of ST? ST equals to 2 plus 1.5x. So we substitute ST in this equation by 2 plus 1.5x. And it is equal to AS plus BT. What is the value of AS? AS equals to 2.5x. AS equals to 2.5x. Therefore, we substitute AS in this equation by 2.5x. Plus BT. Here BT equals to 2x. Therefore, we substitute BT in this equation by 2x. So in conclusion, we found out that 2 plus 1.5x equals to 2.5x plus 2x. 2 plus 2 is 4, so in total, in this side of the equation, we have 4 plus 1.5x. That equals to 2.5x plus 2x. 2.5x plus 2x is 4.5x. So in conclusion, we found out that 4 plus 1.5x equals to 4.5x. Here we subtract 1.5x from this equation, and we get that 4 equals to 4.5x minus 1.5x is 3x. So 4 equals to 3x, so we'll divide this equation by 3. And finally we'll get that x equals to 4 over 3 units in its length. So we actually found out that the radius x of this circle is equals to 4 over 3 units in its length. Our mission is to find out the area of this circle. We know that the area of any circle, the formula for the area of any circle is pi times the radius of the circle squared. Okay, therefore the area of our circle will be equal to pi, and the radius is x, therefore the radius square is x squared. So the area of our circle is x squared, and we just write our formula that x is 4 over 3. X equals to 4 over 3 units in its length. If x is 4 over 3, it means that x squared is 4 over 3 squared. So x squared is 4 over 3 squared. Therefore, the area of our circle is equals to pi times 4 over 3 squared. That is to say, it is pi, and 4 over 3 squared equals to 4 squared, that is 16, over 3 squared, that is 9. So the area of our circle will be equal to either 16 pi over 9 square units, or in terms of numbers, it is equals to 5.585 square units. Repeat again. The area of this circle equals to either 16 pi over 9 square units, or in terms of numbers, the area of this circle equals to 5.585 square units. Okay, so in the next step, I will summarize the lecture. In this lecture, we found out the area of this circle. So in the drawing, we have quadrilateral ABCD. Inside this quadrilateral, we have this circle. In addition, we know that side AB of this quadrilateral is equals to 2 units in its length. Side BC equals to side CD. They are both equal to 8 units in their lengths. And also, this is angle ABC, that is equals to 90 degrees in its size, and this is also angle DCB, also equals to 90 degrees in its size. Again, our mission is to find out the area of this circle. So, in the first step, we did a construction. That is to say, we extended side DA and side CB of this quadrilateral ABCD by a straight line until they touch each other. This is their touching point. We define their touching point, this point as M. Then we define this angle as theta, and we focus on the right big triangle, triangle DCM. On the right big triangle DCM, this angle equals to theta, this angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus theta, according to the rule that the sum of the angles in any triangle is equal to 180 degrees. So, 90 degrees plus theta is 90 degrees, and 90 degrees plus 90 degrees, it is equals to 180 degrees, according to the rules they mentioned, that the sum of the angles in any triangle is equals to 180 degrees. Then we focused on line segment CB. line segment CB is one side of quadrilateral ABCD, therefore it is absolutely a straight line. Then we extended the straight line CB by straight line, and we got the result is line segment CM. When you extend a straight line by straight line, the result must be a straight line, therefore CM is a straight line. Then we focused on the upper side of the straight line CM at point B. And on the upper side of CM at point B, the sum of the angles must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of CM at point B? We have this angle that is a right angle, it's equal to 90 degrees, plus this miscellaneous angle ABM. In total, the sum of those two angles must be equal to 180 degrees, according to the rule that I mentioned. Therefore, the missing angle must be equal to 90 degrees. In order to complete the sum of the angles on the upper side of CM at point B to 180 degrees, the missing angle must be equal to 90 degrees. So inside the right small triangle ABM, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus theta. Okay, according to the rule that the sum of the angles in the triangle is equal to 180 degrees. Then we proved that the right big triangle DCM is similar to the right small triangle MBA. Why? Those two right triangles are similar to each other. First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta, that is a common angle, it belongs to both triangles, so we can write down that the angle theta equals to itself is a common angle that belongs to both triangles. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So we actually proved that all the three angles of the right big triangle DCM are correspondingly equal to all the three angles of the right small triangle MBA. Therefore, those two right triangles are similar to each other according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we conclude that the following relationship exists between their sides. That side DC of the right big triangle DCM over side AB of the right small triangle MBA equals to side CM of the right big triangle DCM over side BM of the right small triangle MBA. Repeat again. We derive that DC over AB equals to CM over BM. DC is 8, AB is 2, and it equals to CM over BM. What is the value of CM? From the drawing it is very easy to see that CM in total equals to CB plus BM. That is to say, CM equals to CB, that is 8, plus BM, that is the missing side. So in total, CM equals to 8 plus BM. Here, CM equals to 8 plus BM divided by BM. So 8 over 2 equals to 8 plus BM over BM. 8 over 2 is 4, so 4 equals to 8 plus BM over BM. Here we multiply this equation by BM and found out that 4 times BM equals to 8 plus BM. Here we subtracted BM from this equation and finally found out that 4BM minus BM is 3BM, so 3BM equals to 8. Here we divided this equation by 3 and finally found out that BM equals to 8 over 3 in its length. The missing side BM equals to 8 over 3 in its length. Then, if we focus on the right small triangle MBA, and we implemented the Pythagoras theorem on this small right triangle MBA. According to the Pythagoras theorem, the small right triangle MBA, AM square equals to AB square plus BM square. Again, the small right triangle MBA, AM square equals to AB square plus BM square. So AM square, that is the square of the hypotenuse, equals to AB square. AB is 2, therefore AB square is 2 square, that is 4, plus BM square. BM is 8 over 3, therefore BM square is 8 over 3 square, that is 64 over 9. So here AM square equals to 4 plus 64 over 9 square, plus 64 over 9. So here we multiplied 4 by 9 and then we divided by 9 in order to overcome factor with 64 over 9. So AM square equals to, so 4 times 9 is 36. So in total, the numerator of this expression will have 36 plus 64 divided by 9. 36 plus 64 is 100 divided by 9. Divided by 9. So AM square equals to 100 over 9. We took a root out of this equation and finally found out that AM equals to the square root of 100 over 9. the square root of 100 over 9 is equals to the square root of 100 that is 10 over the square root of 9 that is 3. So in conclusion found out that AM equals to 10 over 3 units in its length. The hypotenuse AM, the length of the hypotenuse AM is 10 over 3 units. Then we did another construction. That is to say, we drew perpendicular on BC in such a way that the perpendicular on BC will be also tangent to this circle. Okay? Again, we draw perpendicular on BC in such a way that the perpendicular on BC will be also tangent to this circle. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We define the point of tendency of the perpendicular inside BC as T. We define the point of tendency of the perpendicular of this circle as K. Then we extended the perpendicular TK by straight line until it touches side DA. We defined the touching point of the extended perpendicular TK with side DA as point S. By doing this construction, we created the right middle triangle, triangle STM. In the right middle triangle STM, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. Okay, then we define the center of this circle, this point as O, and we define the radius of this circle as X. Then we join points O and H together by straight line. Point O is the center of the circle, point H is the point of the circle itself, therefore OH is the radius of this circle that is equal to X according to our definition. We have the radius OH that is drawn to point H, therefore according to rule 1, whenever we have a radius that is drawn to the point of tendency, then tangent BT will be perpendicular to the radius HO. If BT is perpendicular to HO, it means that this angle equals 90 degrees and this angle also equals to 90 degrees. Likewise, we join points O and L together by straight line. OL is the radius of this circle that is equal to X, according to our definition. The radius OL is drawn to point L, therefore according to rule 1, this angle equals to 90 degrees and this angle also equals to 90 degrees. Likewise, we join points O and K together by straight line. OK, line segment OK is the radius of this circle that is equal to X. The radius OK is drawn to point K. Therefore, according to rule 1, this angle equals to 90 degrees and this angle also equals to 90 degrees. We focus on this small quadrilateral OKHT. This quadrilateral OKHT, we have 1, 2, 3 right angles. Therefore, the fourth angle must be also equal to 90 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So inside quadrilateral OKHB, this quadrilateral, we have 4 right angles, therefore we can relate to this quadrilateral as a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. That is to say, side OK must be equal to the opposite side HT in rectangle OKHT. But OK is X, therefore HT must be also equal to X. Likewise, we focus on quadrilateral LOBH. In this small quadrilateral LOBH, we have 1, 2, 3 angles, therefore the fourth angle must be also equal to 90 degrees. Therefore we can relate to this quadrilateral as a rectangle, because it has 4 right angles. And we also know that the opposite sides of a rectangle are equal to each other. That is to say, side LO must be equal to side BH in rectangle LOBH. But LO is X, therefore BH must be also equal to X. So in conclusion, found out that BT, the length of line segment BT is X plus X, that is 2X. Here, BT equals to 2X units in its length. Then we proved that the right middle triangle STM is similar to the right small triangle, triangle MBA. Why those two right triangles are similar to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. In addition, this is the angle theta, that is a common angle, it belongs to both triangles, so we can write down that angle theta equals to itself as a common angle that belongs to both triangles. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So we proved that all the three angles in the right middle triangle STM are correspondingly equal to all the three angles in the right small triangle MBA, therefore those two right triangles are similar to each other according to angle similarity rule. And from the fact that those two right angles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that ST over AB equals to TM over BM equals to SM over AM. ST is the missing side, so we leave it as it is. AB is 2, and it is equals to TM over BM. What is the value of TM? What is the length of TM? From the domains it's very easy to see that TM in total equals to 2x plus 8 over 3. Again, TM equals to 2x plus 8 over 3. So here, TM equals to 2x plus 8 over 3 over BM. What is the length of BM? BM is 8 over 3. Here BM is 8 over 3, and it is equal to SM over AM. What is the length of SM? From the domains it's very easy to see that SM equals to SA plus 10 over 3. Okay, SM equals to SA plus 10 over 3 over AM. AM is 10 over 3. Here AM is 10 over 3. So in conclusion, found out that ST over 2 equals to 2x plus 8 over 3 over 8 over 3. It is also equals to SA plus 10 over 3 over 10 over 3. We can derive this equation. Actually, those two sides in this long equation, those two sides that they are equal to each other. Therefore, we can derive equation 1 from, we can create equation 1 from those two sides that are equal to each other. So according to equation 1, ST over 2 equals to 2x plus 8 over 3 over 8 over 3. So in this side of equation 1, we have 2x plus 8 over 3. Here we multiply 2x by 3 and then we divide it by 3 in order to have a common factor with 8 over 3. 2x times 3 is 6x, so in total, in the numerator of this expression, we have 6x plus 8 over 3 divided by 8 over 3. So, in this side of equation 1, we have 3 in the numerator and 3 in the denominator, so 3 will get cancelled. And we left only with ST over 2, that's equal to 6x plus 8 over 8. Here, we cross multiplied this equation in equation 1 and found out that 8 times ST equals to 2 times 6x plus 8. Here we divided this equation 1 by 2 and found out that 8ST over 2 is 4ST, 2 over 2 is 1, so here in this side of equation 1 we left only with 6x plus 8, so 4ST equals to 6x plus 8, here we divided this equation by 4 and finally found out that ST equals to 6x over 4 is 1.5x and 8 over 4 is 2, so in conclusion found out that ST equals to 2 plus 1.5x. Here ST, the length compliant side with ST, the length compliant side with ST is 2 plus 1.5x. Then we continue to focus on the long equation that we created here. On this long equation, those two sides, they are equal to each other, so we can create equation 2 from those two sides that are equal to each other. So according to equation 2, we get that (2x plus 8 over 3 over 8 over 3 equals to SA plus 10 over 3 over 10 over 3. So in this set of equation 2 we have 2x plus 8 over 3. Here we multiply 2x by 3 and then we divide it by 3 in order to have a common factor with 8 over 3. 2x times 3 is 6x, so in total in the numerator of this expression we will have 6x plus 8. 6x plus 8 divided by 3, and we have to divide it also by 8 over 3. In the other side of this equation, equation 2, we have SA plus 10 over 3. Here, we multiply SA by 3 and then we divide it by 3 in order to have a common factor with 10 over 3. 3 times SA is 3SA. So in total, in the numerator of this expression, we will have 3SA plus 10 divided by 3. And we have to divide it also by 10 over 3. So in this side of equation 2 we have 3 in the numerator and 3 in the denominator, so 3 will get cancelled. In the other side of this equation we have of this equation 2, we have 3 in the numerator and 3 in the denominator, so 3 also we get cancelled. So what is left from equation 2 after we cancel 3 from both sides of this equation? What is left is actually 6x plus 8 over 8, that is equal to 3 times SA plus 10 over 10. Here we cross multiply this equation 2, and found out that 10 times 6x plus 8 equals to 8 times 3SA plus 10. Here we divided this equation 2 by 2, and finally found out that 10 over 2 is 5, inside the brackets we have 6x plus 8. In the other side of this equation 2, we have 8 over 2, that is 4, and inside the brackets we have 3SA plus 10. Here we open the brackets on both sides of this equation 2, and found out that 5 times 6x is 30x, plus 5 times 8 is 40, that's equal to 4 times 3SA is 12SA, plus 4 times 10 is 40. So here we have 40 on both sides of the equation, so 40 we get cancelled. After we cancel 40, we left only with 30x, that is equals to 12SA. Here we divided this equation by 12, and finally found out that SA equals to 30x over 12, that is 2.5x. So the length of line segment SA is 2.5x. Here SA equals to 2.5x in its length. Then I copied the small quadrilateral ASBT, this small quadrilateral ASBT with the circle that is inscribed inside it in a new page, and we implemented rule 2 in this drawing. So actually, this is the small quadrilateral ASBT with the circle that is inscribed inside it, that I copied from the original drawing. Here we implemented rule 2. If we focus on the common standpoint point A, we have two tangents to this circle, tangent AK and tangent AM. And according to rule 2, they are equal to each other. That is to say, AM equals to AK. So if we define the length of side AK as A, then AM must be also equal to A. So in conclusion, we found out that AM equals to AK equals to A. Then we focus on the common standpoint point B. On the common standpoint point B, we have two tangents to this circle, tangent BM and tangent BG. And according to rule 2, they are equal to each other. That is to say, BM equals to BG. So if we define the length of BM as B, then BG must be also equal to B. So in conclusion, we found out that BM equals to BG equals to B. Then we focus on the common standpoint point T. From the common standpoint point T, we have two tangents to this circle, tangent TH and tangent TG. And according to rule 2, they are equal to each other. That is to say, TH equals to TG. TH equals to TG. So if we define the length of TH as C, then the length of TG, the length of tangent TG must be also equal to C. So in conclusion, we found out that TH equals to TG equals to C. And finally, we focus on the common standpoint point S. From the common standpoint point S, we have two tangents to the second, tangent SK and tangent SD. Tangent SK and tangent SH. And according to rule 2, they are equal to each other. That is to say, SK equals to SH, according to rule 2. SH equals to SK. So if we define the length of SK as D, then SH must be also equal to D because they are equal to each other. So in conclusion, we found out that SH equals to SK equals to D. Then we added side AB to side ST in this quadrilateral AB ST. What is the value of AB plus ST? AB is A plus B and ST is C plus D. So in total, AB plus ST equals to A plus B plus C plus D. In the next step, we added side AS to the opposite side BT. What is the value of AS plus BT? From the drawing, it is very easy to see that AS plus BT in total it is equals to A plus B plus C plus D. Again, AS plus BT in total equals to A plus B plus C plus D. So AS plus BT also equals to A plus B plus C plus D. So those two expressions, they are both equal to A plus B plus C plus D, therefore they are equal to each other. That is to say, AB plus ST equals to AS plus BT. Repeat again. I shall found out that AB plus ST equals to AS plus BT. AB is 2, so we substitute AB by 2, plus ST. ST is 2 plus 0.5x, therefore we substitute ST by 2 plus 1.5x. And it is equals also to AS plus BT. AS is 2.5x, therefore we substitute AS by 2.5x plus BT. Here BT is 2x, therefore we substitute BT by 2x. So in conclusion, we found out that 2 plus 2 plus 2 plus 2 plus 1.5x equals to 2.5x plus 2x. 2 plus 2 is 4. So in total, this is the equation we have 4 plus 1.5x. This is equals to 2.5x plus 2x is 4.5x. So in conclusion, we found out that 4 plus 1.5x equals to 4.5x. Here we subtracted 1.5x from this equation. And finally found out that 4 equals to 4.5x minus 1.5x is 3x. So 4 equals to 3x. Here we divided this equation by 3 and finally found out that x equals to 4 over 3 units in length. That is to say, the radius x of this circle equals to 4 over 3 units in length. Our mission is to find out the area of this circle. Actually, the area of any circle is equals to pi times the radius of the circle squared. Therefore, the area of our circle will be equal to pi, and the radius is x, therefore the radius squared is x squared. So the area of our circle equals to pi x squared. And we have already found out that x equals to 4 over 3. If x equals to 4 over 3, it means that x squared is 4 over 3 squared. Therefore, the area of our circle, that is pi x squared, will be equal to pi times 4 over 3 squared. So the area of our circle equals to pi over 3 squared, pi times 4 over 3 squared. So it is pi, and 4 over 3 squared equals to 4 squared, that is 16, over 3 squared, that is 9. So in conclusion, we found out that the area of our circle equals to either 16 pi over 9 square units, or in terms of numbers, it is equals to 5.585 square units. I repeat again, the area of this circle equals to either 16 pi over 9 square units, or in terms of numbers, it is equals to 5.585 square units. Okay, thank you very much.